Hello, this is Ray Ko, and today we will be going over some ideal gas problems using PivNert. Oops. Okay. So, what does PivNert mean? So we're basically just going to go over what each of these variables stand for. It's pretty self-explanatory, but let's do this. So pressure is, P is for pressure, and pressure can be measured in ATM, or atmospheres, millimeters per mercury, and torr. We should be able to know how to convert between the three. Torr and millimeters per mercury are essentially the same thing. So we can just use 1 atmosphere is equal to 760 millimeters per mercury, or 760 torr. Volume is in liters, always liters. If you see it is, if the volume is in milliliters, make sure to convert it to liters. N is number of moles. R is the gas constant, and it is basically the proportionality between the pressure that relates to pressure, volume, number of moles, and temperature. It changes depending on the units you use for pressure. So if you use atmospheres, which I tend to use, it's 0.0821 atmospheres, or 4 atmospheres, and 62.363 for torr or millimeters per mercury. And temperature, it's pretty easy. Just make sure you always to put it in Kelvin. And if the problem gives you Celsius, then make sure to add 273 so you can get it to Kelvin. Let us go into the practice problems now. Okay, so assuming ideal conditions, 2.4 milliliters container of H2 is under a pressure of 2.3 atmospheres at 56 degrees Celsius. How many moles of H2 are in the container? So let's just plug in our values, right? So we have our pressure, we have our volume, we have our moles, which is what we're trying to solve for, we have our gas constant, we're using ATM, so let's just use 821 and then 56. And if you did this, you would be wrong, dead wrong. And go ahead, so there are 2 mistakes with this equation. Go ahead and pause the video to see if you can find the mistakes. Okay, so if you found that there's a mistake with the volume and with the temperature, you would be correct. And why is this the case? Well, here we have milliliters and here we have Celsius. So we have to convert those into liters and Kelvin respectively. So an easy fix for that would just be dividing this by 1,000, because there are 1,000 milliliters in 1 liter. We just add 273 onto this side. And so what I like to do, I like to solve for n so that we have, we can just plug it into the calculator really easily. So let us do that. 2.3, 2.4 over 1,000. Oops. $56 plus 273. And oops, it's a weird 3. And so we just plug that into the calculator and we get 2.0 times 10 to negative 4. Remember, we want 2 significant figures because all the values that are given are in 2 significant figures, so this would be the correct answer. Don't forget units, moles. Next problem. Assuming ideal conditions, a 3.2 liter container of 0.8 mole of H2 is under a pressure of 300 torr. What is the temperature of the container? Okay, so here we have 300 torr. Now if you remember the conversion, it will be 300 divided by 760. And we want liters. Don't know what that was. 0.2. It is in liters, so that's good. We have our moles, and so here don't get fooled, even though it says torr here, because I converted it into ATMs, I will still be using the gas constant, 0.0821, and multiplied by T, which will be the temperature. And so let's just solve for T. all over 0.8 moles multiplied by the gas constant. And at the end, we should get an answer where T is equal to 19C. And if you did this, you would be wrong. So go ahead and pause the video to try to find out if, see if you can find the mistake with, there's a mistake somewhere in my work. Now, if you've identified that this here is Celsius rather than Kelvin, you would be correct. We do not like this C right here, and it has to be in Kelvin. Remember that. Temperature is always in Kelvin. Last problem for today. So assuming ideal conditions, a container of 1.2 moles of H2 is under a pressure of 2.1 atm at 48 degrees Celsius. What is the volume of the container? All right, so we have 2.1 atm, pressure atm, volume, what we're trying to solve for, 1.2 moles. Gas constant, we're using ATM, so use 0.0821. And we want to multiply by the temperature, which is 48. Now, we have to remember that this is Celsius, so we have to add 273 to our temperature. Now, simply just solve for V, so we just divide. We just divide this 2.1. We just divide both sides by 2.1. And so we can basically just ignore these two. So now we solve for volume, and we just plug this thing into the calculator. And what we'll get is 15.05 liters. And if you're going off of sig figs, technically it would be 15 liters. But yeah, this is how you would do that. Did I forget volume? Oh, no. Nice. Okay. So that is it for the ideal gas practice problems for PivNerd. I hope you enjoyed. And yeah, thank you.